Hello everybody, today I talk about wave functions in quantum mechanics and Hermitian apparatus in quantum mechanics. So, wave function in quantum mechanics analogize the wave particle duality of matter by supposing that rather than traveling along a definite path, a particle is distributed through space like a wave. The wave that in quantum mechanics replaces the classical concept of a particle trajectory is called a wave function. Uh, Omega, this it is mean psi. A wave function in quantum mechanics describes the quantum state of an isolated system of one or more particles. There is one wave function containing all the information about the entire system, not a separate wave function for each particle in the system. The wave function for the harmonic motion here we can show formulation d square times psi x over dx square equal minus brackets open 2p over rho brackets closed square times psi x. So minus brackets open rho square over 4p square brackets closed times d square psi x over dpx square equal psi x. Here we you notice that main formulation equal 1 over mv square plus v equal p square over 2m plus b. We have a result formulation here minus brackets open h square over 8p square times m brackets closed d square times psi x over dx square equal brackets open e minus v brackets closed times psi x. So state and wave function. The state of a quantum mechanical system is completely specified by a wave function psi that depends on the coordinates of the particles and time. These functions are called wave functions or state functions. Wave function contains all the information about the system. Wave function in quantum mechanics, classical trajectory is Newtonian mechanics. Implications of Born's interpretation. First, positively, P are large or equal to zero. The sign of wave function has no direct physical significance. The positive and negative regions of these wave functions both correspond to the same probability distribution. Second, normalization. Here we can show formulation integral uh, psi prime times psi d torque equal 1, etc. The probability of finding the particle in the universe is 1. So next we have an operator, a rule that transforms a given function into another function. Here we have examples. First operator d over dx and function x square. Second operator d square over dx square and function uh, 4 times 2. Third operator d over dy times x and function xy square. Fourth operator I h bar times d over dx and function exponential minus I kx. Fifth operator h bar square times d square over dx square and function expansion minus kx. So Hermitian apparatus have two properties that forms the basis of quantum mechanics. eigenvalue of a Hermitian operator are real, and eigenfunctions of Hermitian operators are orthogonal to each other or can be made orthogonal by taking linear combinations of them. A Hermitian operator satisfies integral r times a g dx equal integral g times af times dx if phi and g are well behaved. Last, we have eigenfunctions and eigenvalue. Here, fix equal kfx. Fx is an eigenfunction of a with eigenvalue. We have eigenfunctions main formulation operator times function equal constant factor times same function. Here we have an example. E power of kx is an eigenfunction of operator px equal minus I h bar times d over dx. Fx equal e power of kx. It is the result formulation h k squared times e power of I kx. Here e power of I kx is an eigenfunction. So that's all. Thank you for your attention.